Hi, my name is Jesse Ninomaki, and I'm here to introduce the Band in a Box project for Team 5. If you look on slide 2, you can see that the goal of this project is to design 4 instruments that can play all of the notes of a chosen song accurately and are all able to fit within a small box. And on slide 3, we'll go a little bit more in depth into the requirements of this project. So again, you have to build 4 instruments. All 4 instruments must fit within a 2-foot by 2-foot by 2-foot box and be cheaper than $15 in cost. Additionally, we can use no more than 10 feet of PVC pipe or 6 feet of piano or guitar string for all 4 instruments combined. And one of the instruments, 1 wind, 1 percussion, and 1 string instrument must be made. The 4th instrument can be any one of those 3 types of instruments. And finally, the song that we chose to play is Ode to Joy. Of our design goals for each of the instruments, that's on slide 4, the top 2 are the ability to play all of the notes accurately, and they must cost less than $15. Those are the top 2 criteria that we're going for, but additionally we want good quality of craftsmanship, them to be aesthetically pleasing, and to be creative in design.
Hi, my name is Clint McCandless, and I will be presenting option 1 for team number 5's Band in a Box project. If you refer to the slide entitled Option 1 Instrument Sketches, you'll see the 4 sketches of the instruments that compose option 1. Of those instruments are the pan flute and the diddly bow, included there on the left, and the diagrams of the harmonica and the xylophone you'll see on the right. On the next slide, discuss the underlying physics. So for the pan flutes, this is our mid-range instrument. Blowing air into the pipe causes the air in the pipe to vibrate, which creates a standing wave inside the pipe between the two holes. The wavelength is determined by the length of the pipe, as well as the condition of the endpoints, whether they're open or closed. In this case, only one end will be open if we choose this option. And the diameter of the pipe also affects the wavelength as well. On the next slide, underlying physics continued. We see the diddly bow. This is our low range selection for option 1. In a diddly bow, similar to a guitar, plucking the string causes it to vibrate, creating a standing wave between the 2 nodes, the 2 nodes being the bridge near the area where you pluck the guitar or the diddly bow, and the neck of the guitar. The frequency specifically is determined by the distance between those 2 nodes, which can be changed using frets. So a short distance equals a smaller wavelength, which equals a higher frequency, which equals a higher pitch. Some other factors that affect the frequency are the tension of the string, as well as the thickness of the string, and the linear mass density, the mass per unit length. Again, like I said, using frets lets us adjust the pitch by adjusting the distance between those 2 nodes. And you'll see the diagram to the right there for the diddly bow. On the next slide, you'll see a simple model of a harmonica. Harmonica is actually a very complex instrument. We chose this for the high range. The standing wave is created by the vibration of a reed which chops up the air. The frequency is determined by the velocity of the air passing over the reed. So faster velocity equals a shorter wavelength, which equals a higher frequency and thus a higher pitch. And you'll see the diagram there on the right. The final option is the xylophone, a simply supported xylophone to be specific. This is another mid-range instrument that we've chosen for option 1. The standing wave is created by the vibration of the bar between the 2 nodes where the supports are. So the frequency for this instrument is determined by, again, similar to the stringed instrument, the distance between the nodes, as well as the thickness of the bar, the speed of sound in a chosen material. For example, the speed of sound is faster through a solid material, usually relative to air, as well as the shape of the bar itself. So on the final slide entitled Option 1, Estimated Budget and Materials List, you'll see a detailed breakdown of each of the materials we're most likely to include, as well as each instrument's breakdown using each of those materials, and then finally the total cost. Our objective was to stay under $15 for each instrument, and I tried to be as conservative as possible, and still each of our estimates came in well under $15. And then underneath the breakdown of the cost is the detailed materials list for the xylophone, the pan flute, the diddley bow, and the harmonica. So that concludes my presentation for option 1. Thank you very much.
Hi, my name is Shonda Leaks, and I'm with Team 5, illustrating instruments from option 2. As you can see in the slide behind me, which is slide 1, there is 4 instruments that were selected: the recorder, the hammer dulcimer, the ukulele, and the xylophone. All 4 instruments will fit into an 8 square foot box. The max length that I'll be using is 23 inches for one of the instruments. The max width is 22 inches, and the max height is 21 inches for the total. So there's plenty of room in the box for all 4 instruments to fit. Each instrument to manufacture it comes to less than $15 a piece, and the total value for all 4 instruments will be $35.72 thanks to Home Depot and Amazon. In slide 2, which is the recorder, the material that was used is PVC and wood because there's a little cork in there, and the total value for this is $4.95, and yet it met the $15 for budget. In slide 3 is the hammer dulcimer. The material that was used is wood, string, and glue. The total cost for this project is $9.77. In slide 4, it is the ukulele. You can see the total price is $14.76. And the material that was made for this one would be wood, string, keys, and screws. In the 5th and final slide is the xylophone. The material that was used is wood, glue, and screws. The total price is $6.24. So in all 4 instruments, it met budget and met the design specifications. Thank you.
Hi, I'm Andrew Helton, and I'm just going to be wrapping up everything that you've seen so far for the Team 5 Band in a Box project. So, you've seen the options we've presented, and on slide 1 we can see an array of instruments that we chose to compare. As you can see, we had a variety of string and wind instruments, as well as a couple of fairly similar percussion instruments. But how do you choose one combination among all of those that fit within our criteria? Well, on slide 2, you can see some of the options and designs and combinations that we went through. Each of those combinations was put together and specifically designed so that it would meet all of our criteria. On slide 3 is just another reiteration of those criteria that I'm sure you've heard so many times already. Each combination will fit within a 2x2 by 2 foot box, use less than 10 feet of PVC and less than 6 feet of piano or guitar string altogether, and each instrument is designed to cost less than $15. Each combination also has at least 1 instrument from each category: wind, percussion, and string. And finally, each instrument can play its required notes to our chosen song, Ode to Joy. Well, since the calculations and other objective standpoints have already been addressed, it really comes down to our personal favorites, and that comes to the more subjective side of things. On slide 4, you can see that we've chosen to use the following combination, and that is harmonica to fill both the high and wind instrument slots, pan flute for the first mid-range and second wind instrument slot, a xylophone for the second mid-range and percussion slot, and the diddley bow, real fun name to say, for the low and string instrument slots. Thank you all for your attention, and we hope you're looking forward to the final product of Team 5's Band in a Box project. That's all.